There it is. All right. Hello everybody. Welcome to this month's meeting with TACDA from all across the U.S. We've gotten a lot of fantastic replies in chat of it where everybody's tuning in from. For those who don't know me, my name is Parker Twiss. I'm on the board of directors for TACDA. And so first, the necessary disclaimer to get everything started for this meeting. Nothing in this presentation should be considered legal, medical, or financial advice. The opinions of the viewers can differ considerably and do not necessarily reflect the opinions of TACDA. You should always do your own research and consult with professionals. In order to maintain the flow of the presentation, we kindly request that questions be held until the designated question and answer period, which we'll have after the lesson. You are welcome to enter questions in the chat at any time, and they will be reviewed after the presentation when we can address those. So today we are joined by Paul Seyfried, where he will be teaching us about planning for extended power outages and the intricacies and everything involved with that. And as things are, it's kind of an unsure time, and power outages happen both in the best of times and also in the worst of times. So we're very, very grateful to have Paul here to teach us the ins and outs on how best to prepare for that. So thank you very much, Paul. Take it away. He is a TACDA board member and NBC nuclear, biological, and chemical shelter expert as well.
Okay. So with all the international tensions going on right now, I thought it would be prudent to review what EMP is, because it seems to be featured prominently in the order of battle for all the major world powers that have nuclear weapons. So I just want to quote briefly from the open testimony of Dr. Lowell Wood from Lawrence Livermore National Laboratory, who was at one time the chairman of the Congressional Commission to assess the threat of EMP to the United States. And he does a really good job of defining and clarifying what EMP is and what its effects are in a fairly compact page. So he starts off here, EMP is really static electricity everywhere all at once. Without needing to understand the undeniably esoteric means by which EMP arises in various military circumstances, it suffices to recall that it presents itself as something closely akin to static electricity, extremely intense, but exceedingly brief, everywhere within line of sight to a high-altitude nuclear explosion, all at once. The static electricity pulse is carried on radio frequency electromagnetic waves of uniquely high intensity. The bomb's extraordinarily intense prompt radiations essentially transform the entire atmosphere beneath it into a gigantic radio transmitter antenna radiating at maximum possible intensity for a very brief interval. The bomb's fireball, expanding rapidly in the presence of the Earth's magnetic field, gives rise to a second manifestation of EMP, which is of particular significance for long metallic lines such as electrical and telephone systems. Extended metallic structures within line of sight of the explosion, telephone and electrical lines, radio and TV antenna, fence wires, railroad tracks, then serve to gather up the broadcast energy of EMP and deliver it into whatever they are connected to, often with locally ruinous results, which appear retrospectively to be basically similar to those resulting from a lightning strike. However, since the damage occurs thousands of times more swiftly than that of lightning, most types of lightning protective devices are essentially useless. Since it travels at the speed of light, EMP arrives essentially instantaneously from the general direction of the explosion. EMP can blanket an entire U.S.-sized continent from a single source. EMP originates primarily in the interaction of gamma radiation from a nuclear explosion with the Earth's atmosphere at altitudes of a few dozen kilometers and propagates predominantly toward the Earth's surface. The low-frequency long-time component of EMP arises from the fireball's interaction with the Earth's magnetic field, as already noted. Thus, since you can readily see a bomb explosion a few hundred kilometers above the central U.S. from anywhere in the lower 48 states, The EMP arising from that explosion's interactions with the Earth's atmosphere can also see you. To be sure, at greater distances, the intensity of the pulse will be smaller, but usually not as indicated by the familiar inverse square of the distance law. Likewise, its severity is generally not well related to the yield or total energy production of the bomb. The initial sharpness of the EMP actually depends rather sensitively on esoteric aspects of the bomb's design and operation. Low yield, specially designed bombs may pose a larger or even larger EMP threats at both low and high electromagnetic frequencies, as do high yield ordinary ones. EMP does not linger since it arises from a nuclear explosion's prompt emitted gamma radiation interacting with the Earth's atmosphere. Nuclear EMP goes away very quickly. It is a phenomenon of compelling interest only for timescales in the order of microseconds or millionths of a second, although its long-time component may be present for milliseconds, thousandths of a second. Within these time frames, however, it can be quite dramatic in its effect. It has none of the lingering characteristics of nuclear radioactivity or fallout. EMP is not sensed by people and it does not damage the human body. EMP is much more threatening to large electrical systems than small ones. Because metallic objects of many different shapes can effectively gather up and then concentrate the energy associated with EMP, physically large systems comprised of metal lines, cables, wire, and dish antenna often manifest exceptionally great vulnerability to EMP damage. Their spatially extended components harvest the EMP energy broadcast by the bomb atmosphere interaction, which falls fairly uniformly over wide areas, and bring it to wherever the system's barn may be. And often centrally located components of the extended system, which may be quite sensitive to electrical overload conditions. Physically small systems usually don't get EMP illumination so well collected or focused within themselves, and thus tend to be more durable to its effects. An obvious exception to this is safer rule of thumb and communication systems, whose antenna and highly sensitive front ends almost unavoidably make them more vulnerable. Now, most of us in this meeting are familiar with the 1859 Carrington event, which was basically a very large, intense solar storm that was known to melt telegraph wires in North America because of its intensity. And many telegraph stations were burned to the ground as a result. When you reflect on that, consider that the only buildings in North America in 1859 that had electrical wires in them were telegraph offices. So if you can jump forward to 2026, most of the buildings in North America have wiring in them and a lot of wiring in them. So there's a potential of having a lot of fires and of course the ability to fight fires will be extremely limited because the grid will be down. I'm going to jump forward in his testimony to one paragraph here about our civilian infrastructure. And he says the EMP robustness of the civilian infrastructure of the United States can be summarized far less equivocally. It is entirely non-existent. Our civilian telephone, electricity, broadband communications, and electronics plants are all naked to our nuclear-armed enemies. They were neither designed nor engineered nor constructed, nor are they operated so as to survive nuclear explosion effects even at very great distances. For the invisible hand of the marketplace provides no incentives for EMP robustness, nor penalties for failing to so prepare. Large electric power and telephony systems are known to fail under the effects of solar storms, which impose far smaller electromagnetic stresses than are known to arise from high-altitude nuclear explosions of even modest scales. Consequently, even a modest single explosion EMP attack on the U.S. might well devastate us as a modern post-industrial nation. So Um, the big question here is why is the grid so critical? And I think I wish I had a slide that was shown by Jim Phillips that had all the different components of the infrastructure as we know it, the power grid, the petrochemical industry, the oil refineries, the medical fields, the manufacturing, the financial systems and everything. And he had all these lines going everywhere, showing the interdependability of all these different um, facets of our civilization that are all interdependent upon each other. For example, water treatment plants are dependent upon the power company, and they're dependent upon the chemical plants to supply the chlorine and other chemicals that's used to treat drinking water. And all those in turn are dependent upon the power grid for manufacturing all these systems and products. And so basically everything that keeps us alive today in our modern world is completely dependent upon the power grid. Um, so that would include communications, drinking water, financial services, that of course supports commerce, medical services, dental care. I had a perfect example of this Monday where I had a bad tooth that had to be extracted, and it was a very complicated procedure, turns out. But if I didn't have a functioning power grid and a functioning society, I'd been in real trouble. My life would have been held at risk if I couldn't get that tooth out of there. Manufacturing, fuels for energy and transportation. So nothing moves in the transportation system without diesel fuel and gasoline. Um, or in California, electricity. Uh, Food production, processing, packaging, and transportation. All that depends on diesel fuel. It's been said that your average meal travels some 1,400 miles on 7 different diesel-powered trucks before it gets to your grocery store. None of that will happen when the fuel supply stops. I know that my Costco store a few miles away gets 4 double tanker fuel trucks delivered to that station every day to supply fuel to all their customers. So that's about one every 2 hours, which is kind of a sobering reminder of just how fragile our system is. Pharmaceuticals. How many people depend on pharmaceuticals every day for heart medication, diabetes, and a plethora of other health maladies. Um, so I know that, I spent the last 3.5 years working for a pharmaceutical company, and it was interesting to me that the computer programs that we had to download on our production equipment for packaging our products had to come from Pakistan. So that's that just shows how connected we are with all these global systems. So the question is, what does all this mean to my house? Um, Edwin York said that when EMP arrives off the power line to the weatherhead on your house, you're looking at about 2 million volts and about 45,000 amps at the weatherhead hitting your house, which means that every appliance in your house that is plugged in to wall outlets are basically destroyed. Um, so the E1 component of EMP, there are 3 major components of EMP. E1 is the short term, high voltage, low amperage component. So you're looking at millions of volts, but only thousands of amps. And that, of course, the rise time on that is about 5 nanoseconds. So that is all done and through your house and all your electronics long before any lightning suppression systems begin to clamp. The E2 is similar to lightning in both its rise time and its duration. It's about 100 milliseconds and it's gone. E3 is the low voltage, high amperage component of the signal. So you're looking at tens of volts per mile of power line being absorbed by that mile of power line, tens of volts. But you're looking at thousands of amps per mile of power line, which explains why the extremely high voltage power lines, power transformers at these power plants, and there's like 6,000 of them, these just melt down into a blob of copper and iron. It's basically a puddle of molten metal. So those are completely destroyed, and they take 1 to 3 years with the world economic system up and running to replace. It's the E3 component that causes the wiring in your house to glow like toaster wires for up to 20 minutes. And if I can go back one picture, Roseanne. Yeah, that one. So that one shows a simulation of E3 on an EMP simulator at the White Sands Missile Test Range on your breaker box on your house. So you can imagine that photo being your breaker panel on your house for 20 minutes. You're probably not going to reach over and touch it and try to shut it off, or it won't matter anyway because the contacts are probably spot welded closed anyway, but that's a pretty serious condition. Now, there is something you can do to prevent the E3 damage to your house, and that would be the installation of an isolation transformer. And they're not cheap, but if you put that in the power line before it gets to your house, then that would mitigate that damage. In the unfortunate event that your house happens to be built very close to your neighbor's house and he doesn't have the same protection and his house catches fire, then your house is probably going to burn too, as well as the whole neighborhood. I like to say that every American has all of the food, water, and medicine that they need for the rest of their lives. And that may be 2 or 3 days, or it may be several years. That's up to you. But there's few things here that you need to consider in your preparation. First and foremost is water. We all know that we won't last more than 2 or 3 days without water. Now, most of my neighbors have a drum or two of water stored in their basement, and of course they're very quick to point that out. I've got 2 drums of water in my garage, but that's really a short-term solution to a long-term problem. And the reason being is that our water comes to us from dozens of miles away. We don't live in an era where, we have a well outside like they did 100 years ago or 200 years ago. We don't live near the river or the stream. We live 50, 60 miles away from the reservoirs in the mountains, and now that water is piped in 6-foot diameter conduits from the reservoirs all the way down Parley's Canyon to the treatment plants. So in my visit to the West Jordan City Water Utility in 2016, I spoke with an engineer for about 45 minutes, and he revealed that we get 82% of our water from the reservoirs and 18% from the city wells if they had to use them. So I asked the question, what if we had a 7.5 earthquake on the Wasatch Front for several minutes? And he said, well, it would take 4 to 6 months to repair those aqueducts coming down from the reservoirs, but we could keep the city alive on just the wells if no, if we had enough diesel fuel coming to the generators at the well houses, if we didn't have too many water main breaks throughout the city, and if no one took a shower. So you got 120,000 people in the city of West Jordan. Hopefully, you won't have too many people cheating on that. But I said, so what about an electromagnetic pulse? And I got a cold stare, and he said, the city will die. And I waited about 20 seconds to see if there was a workaround that would come out of his mouth. But what I got was a explanation as to all the vulnerabilities in the water system from the digitally controlled motors that open and close the valves that control the flow of water throughout the system, and the treatment plants, and the huge computerized command centers that coordinate all these activities. And all the generators at the well houses are packed full of circuit cards that are not shielded, and there's no surge suppression equipment on any of the generators. So they'll lose the generators, they'll lose the fuel depots, they'll lose everything that the water system depends on to function. Um, so we've all heard the rule of thumb that we should have 1 gallon of water per person per day allocated for emergency use. And that is an extremely optimistic um, rule, I think, because having lived off grid for some time, I've I've realized that you're going to need a lot more than that practicality for cooking, washing, occasionally doing laundry, maintaining personal hygiene. And if you have a lot of water, you can have good sanitation with flush toilets. Um, let's see. So your options. If you have a well, your pump will likely be damaged because it's connected to the grid. So I hope you consider having a spare well pump. Um, in the event that your pump is not damaged or you're able to replace your existing well, your portable 5,000 watt generator is probably not even going to start that well motor because it demands so much energy. Um, I think your best option for emergency water procurement would be a solar powered well pump. These are readily available. Some of them run on as little as 400 watts, which is like one or two solar panels in full sun. And they only pump like 1 gallon of water per minute, but they work down to 600 or more feet. And the half-inch diameter tube that you're going to lower down into your well is going to go past the existing well motor that you already have in the well, and get into some good water. Uh, but 1 gallon a minute doesn't sound like much, but in 100 minutes, that's 100 gallons. So you can do several hundred gallons a day, and if you have a underground storage tank in areas that are freezing, you have potential freezing in the winter. Um, you know that's that's going to be plenty of water for your needs. Um, Also, the solar water pump or well pump has a very small footprint as far as storing it in your garage or your barn is concerned. It doesn't take up a lot of space, so it's affordable and easy to set up. If you have surface water, like a lake or a stream, in our case, you're going to need something better than an emergency water filter. like a Berkfeld or Aqua Rain or any of the drip filters because they just don't produce enough water. And there are very stringent limitations on the kind of water that they can filter. For example, if you have industrial chemicals in your water, it's not going to remove those. If you have viruses, hepatitis, HIV in that water, it's not going to remove those. Um, so um, you're going to need something a little more or a lot more sophisticated than an emergency water filter. And I'm going to have Roseanne click ahead a couple of pictures. Yeah, now that is the system that I part of the system. That's one wall. There are three walls. That's the system that we are using to process ditch water that runs all year round. And you see the 120 volt 15 amp well pump there. And so how that works is the water comes up from a 1 inch line through the floor, about center of the picture, and goes over to the left, and that's a 90 micron pre-filter. And that features a stainless steel screen that never has to be replaced. It just collects sand and sediment in there, and when it clogs to the point where you're not getting good flow, you just backfill or backflush all the sediment out the bottom through a valve and resume operation. Then the next filter to the right is a 5 micron pre-filter. I wanted to pre-filter the water down to at least 5 microns before it went into my well pump so that it wouldn't grind up my impeller over time. After that, it runs into a 1 micron filter that's going to capture all your cysts like cryptosporidium and giardia.
Well, I couldn't see a name, but
I'm sorry. Um, so the 1 micron filter doesn't quite get very many bacteria, but it does get the larger cysts and other sediment. And let's see, let's go to the next one. There we go. So the next feature is an inline chlorinator that doses the water to 2 parts per million of chlorine, and that flows into a retention tank where the bacteria and viruses maximize contact time. And then from there, it goes through the nanofiber filter that captures 99.9999% of viruses, RNA, and DNA. And all these large filters that you see are 4.5 by 20 inch, and they have a maximum flow rate of 20 gallons per minute. So you're not going to be running this for a great deal of time, just enough to recharge your 500-gallon storage tank. So after the nano filter, we then go into a 100-pound carbon filter that recaptures the chlorine and several pages of solvents, organic chemicals, fertilizer, pesticides, all kinds of things that I don't want to be drinking in my water. And we'll go to the last slide. So after it goes through the chemical or the carbon filter, it goes through a UV reactor, which murders all life forms, including Cryptosporidium and Giardia. And then it falls into the 500-gallon storage tank. Now, the small 3-gang filter that you see under the reactor is another bank that filters the water as it comes out of the tank. So it takes one more swipe at the water, again, down to nanoparticle level before the water heads off to points of use. I chose to use a 12-volt RV pump because they're inexpensive, and I have like a dozen of them for spares. And it runs off of 12 volts DC, which is readily available. So that's the system that I put together. I've had it tested by the state lab. and it came back with 0 coliforms, and my nitrate level was 0.014 parts per billion, which tests better than West Jordan City water. Um, so for those who are interested in putting together a system like this, oh, I'm sorry, the final yield that I get after pulling the water 200 feet from the stream through the 1-inch pipe and pushing it through all these filters, the yield at the end of all this is about 6 to 8 gallons per minute, depending on how clogged all the filters are. But you can do more. You could pump more water through this system in 1 minute than you're going to get from a Berkfeld drip filter in a day. So in that aspect, it's going to be a lot more attractive as an option for supplying your whole family with water for all the needs that you're going to have. I have several things to share with you about emergency water filters that you commonly encounter at preparedness expos and shows and online. And the very popular drip filters and other emergency filters. I won't name names, but when they tell you that a filter will process 13,000 gallons of water, what they don't tell you is that they test that filter with tap water. Because when you ask them specifically if you tested on ditch water, they are masters at evading the question. And a lot of them won't admit that they tested on tap water, but you can tell by the NSF standards that they're quoting. They have to test with NSF standard 54 and 57. We have to test for chlorine absorption. Well, there's not much chlorine in ditch water. So they're not testing it in a ditch. So now I have a lot of experience backpacking and hunting in the high Uinta Mountains with a very popular and expensive filter, a ceramic filter. And they claim that I can pump a gallon a minute from a stream. And that's true. But after you've pumped a quart of water, the filter candle is clogged and you can't get any more water out of it. So you must disassemble the filter and use the little scrub pad and scrub the outer layer of the ceramic candle away, exposing a layer of fresh ceramic underneath that layer. Reassemble the pump, and you can pump 1 more liter, and then you have to repeat that process. So you only are allowed to clean the filter candle up to 300 times before you need to replace the filter candle because it's no longer thick enough to guarantee effective filtration. And that filter only captures bacteria and cysts like crypto and giardia, but it does not capture viruses. So if someone upstream is polluting the stream with waste and they have a virus like hepatitis, then I'm not protected with that filter. So you probably, or it won't filter chemicals either. So just something you need to know about that type of equipment. It's not going to give you the yield that you've been advertised, and it's not going to give you the protection that they advertise unless you very carefully study what they do promise. For example, they claim that it captures microorganisms, but they leave out the viruses. They leave out the chemicals. They leave out industrial chemicals that may have polluted that water source. For example, if you're trying to filter water alongside the I-15 corridor, well, that water is contaminated with road runoff from used motor oil and brake fluid and a host of other chemicals that I just as soon not have to filter out with my kidneys. So beware of glorious advertising on these cheap filters. So basically, you're going to have to become your own energy generator, you're going to have to, a utility, you're going to have to become your own water utility. Can't help you on the pharmaceuticals, other than to say you'd better stockpile the essential pharmaceuticals that you expect to need. I myself, need a little Cinepril for my blood pressure. I have a large cache of that. Um, there is an excellent article in Survival Blog called "The Five Most Common Lethal Infections," and you can find that on Google by typing in "Survival Blog, comma the five most common lethal infections," and it should come right up. And she lists the five most common infections, and she lists several antibiotics that are very effective for treating that condition. So I highly suggest that you review that article carefully, and hopefully your doctor will feel comfortable with writing you prescriptions for those antibiotics. My doctor did, and so I bought them in bulk. Um, I did not hand my pharmacist 9 prescriptions for $8,000 worth of antibiotics at one time. So I filled these prescriptions a little bit at a time, but it does help you build up a useful supply of antibiotics that would handle just about any common infection that you're likely to encounter. Um, so, um, your water utility, if they use a surface water source, uses between 19 and 23 different processes to make your water safe to drink in the city water system. Emergency filters use between 1 and 2 processes, and they don't have the ability to screen out viruses. Most of your water utilities now use also incorporate UV in the treatment of their water because it is so effective and they can use fewer chemicals. Now, uh, several experts from the national laboratories and the city utility engineer told me that you will not be able to survive in the city. And I think mainly that is because they have no ability to deliver water to your residents. That will be down until the grid is replaced, which could take anywhere from 10 to 20 years. And it's very likely that the scientists and engineers and technicians who understand the production and networking of power systems and the building of power plants and all the skills that go into that industry, they will probably likely starve to death before we're able to reconstitute the power grid. So when the power grid is rebuilt in North America, it probably won't be by Americans. So, you need to plan on those areas if you're going to be successful in this endeavor. Now, generators. Generators are very popular. I have a number of them, and I use them when the sun does not shine at the ranch, and sometimes the sun doesn't shine for 4 or 5 days in a winter storm. So I have to use my generator for an hour or so a day to pump up my forklift battery so that I can carry through the next 24 hours with all the things I do with electric power. I think, well, generators have a couple of weaknesses. Number one, the fuel, you can't store a lot of fuel, especially in the city. you're limited to 5 gallons lawfully in your garage. The fire department doesn't like getting blown up by, 500 gallons of gasoline in somebody's garage. Um, so if you live outside the city limits, you're much more flexible in how much fuel you can store. Gasoline is dangerous to store in large quantities. You have to have the proper equipment, the grounded fuel guns, the hoses, everything. The fuel pumps all have to be designed for handling gasoline to do this safely. Static electricity is always a big hazard with gasoline. Diesel fuel is a lot safer. It lasts longer in storage than gasoline. I mean, of course, fuel extenders and restorers are available for both fuels. My preferred one is PRI. So PRI hyphen D is for diesel and PRI hyphen G is for gasoline. And you can reconstitute fuel that has gone bad with those additives. I recommend that you stockpile some of that. But overall, I think the best long-term, most reliable way to generate energy for your needs after the grid goes down is with solar power. It doesn't make any noise. There's no moving parts in it, so nothing breaks. The rule of thumb on machinery is anything that moves breaks. So generators have a lot of moving parts, and generators will all eventually break down, and you won't be able to get parts for those. So I think solar is the way to go. Um, Natural gas is good for routine power outages. If you have a supplier in your area that's always going offline, I like the Generacs and the large 15 to 18,000 watt natural gas generators. They work well. They come on right away when that power fails, and they work well as long as there's natural gas. But when the grid goes, so does the natural gas after a period of time. Now, some natural gas companies run their whole operation off of their own natural gas. They have their own generators and so forth. I don't know how they'll fare on an EMP insult, but we saw in Texas when they had the big winter storm a few years ago, the grid failed. The wind turbines froze up because they weren't designed for operating in cold weather. And the pump stations for natural gas in Texas were not designed for freezing weather, so they froze, and so the whole grid collapsed, and they were in a real mess for 3 weeks, I think. So anyway, natural gas, can be useful, but they don't depend on it. Um, so considering that your house may burn down during an EMP event, I suggest you find a way to store your non-perishable food, your essential equipment, your backup solar well pump if you are going to rely on one of those. Your cold weather gear, I suggest you store all that not in your house. You have an outbuilding or something that's as far away from the house as you can get it. That would be a better place for that. Another way to isolate your home from the effects of EMP, particularly E3, is to go off-grid solar for your home. That's pretty expensive, but it is an option. So if you're off-grid, then you're not going to be harvesting all of that EMP from the grid, that's been sucked up by thousands of miles of power lines right into your house. You'll only have to worry about your standalone system, and you can vastly reduce the amount of EMP gathered by your system by using shielded wiring. So you're not, the wires going from your solar panels down into your charge controllers. They're not exposed to the signal because they're inside aluminum or steel shielding. Um, so there's a lot of things that you can do to improve your family's chances to not only survive but thrive in the aftermath of a EMP or nuclear or cyber attack. Um, those are basically the thoughts that I had for tonight. I'm open to any questions anybody has.
Yeah, we've got quite a few actually in chat. So the first one is Jay was wondering what it was the overall cost of the water treatment system that you showcased.
I think that it's about $6,000. I originally started with a system called the lake water system. You can Google that, lake water system, and it's manufactured by a company called um, Equinox. But I think if you just type in lake water system, it's out of Michigan and it's made in the United States. And their equipment is very good. That included the UV reactor and the three smaller filter jars, the carbon unit, um, and the chlorinator. After several years of fighting with the little 2.5 by 10-inch filters, I mean, they worked, but I was, changing some of the filters at 1,500 gallons because the water in our stream is so filthy. Um, I discovered that there were 4.5 by 20-inch jars available from Water Pure Technologies in Sandy, Utah. So I switched out all the smaller jars for the large jars, and I've gone for several years without having to swap a filter. So that is probably a good rough figure. I'll be happy to tell people where to get all this equipment. I have absolutely no financial connection to any of these companies. I just know them fairly well, and I can just steer you to the right place and save you a lot of headache trying to find all this stuff.
Cool, thank you. Another question is regarding what about using ozone to potentially sterilize water? I believe I'm
Ozone,
understanding.
ozone is effective. I don't use it in my system. I don't know enough about it, but I've heard that that does work quite well. I'm
Let's
just not
see.
aware of any portable, small scale ozone equipment that could be out there. I've just never seen it.
Gotcha. We have Michael wondering how did people survive 100 years ago before we had all this modern technology? It seems that at least some in rural America could go back to living like those in the period of that time.
That is an excellent question. I'm glad you asked it. Um, we've largely lost the skills that our forebears had. They learned how to deal with infections resulting from trauma injuries, but by using older medical treatments like poultices and things like that. I don't know how to make a poultice. I'm sure that there are people around who do, but that would be, a good thing to learn. I'm relying on antibiotics until I figure that out. But yeah, those people lived close to their water sources. They lived close to the land. They produced their own food. Today, there are no farms that are run like a farm. Our farms were 30, 40, 50 years ago. A family farm used to raise their own hogs and their own sheep and their own cows and they grew 5 or 6 different kinds of crops, and so they were basically self-sufficient. But today, with corporate farming being what it is, most farms have one cash crop, and most farmers buy their groceries at Costco.
Yep. I'll definitely be sticking with antibiotics personally. And to that end, actually, we TACDA does link to Jace Medical on their store. Please check them out. That is one of the few reliable companies I've found that can get you a year's supply of many chronic medications that are very, very common. Not the like restricted black box stuff, but the very most common ones for heart pressure, the just common ailments. You can get a full year supply. So check that out at the store. Next question is Where'd you go? Will an EM by Gary, will an EMP damage the solar panels that are connected to the batteries?
Another good question. So I was told by Bronzicotis and Tom, I can't remember his name, at Solarc, that ordinary solar panels are largely immune to the effects of EMP if the wiring is not exposed. For example, if when you get a new solar panel, the wires, the leads on the panel come all coiled up. That's another thing I forgot to mention. EMP does not like to go through a coiled wire for some reason. It's all witchcraft. But if but once you connect those leads to a long run of wire, then those leads act as an antenna and gathers EMP energy and damages the panel, so it doesn't work, at least not very well. Now, Solarc manufactures hardened panels and hardened inverter and charger assemblies. The charge controller and the inverter is all one unit, and they claim to have tested these on government EMP or independent lab EMP simulators up to 100,000 volts, 132 times without a failure. So I spent a whole afternoon talking with Tom about this at a show, and he was, I mean, I'm not an expert on this by any means, but he sounded like he knew what he was talking about. And Bronzicotis and Ed York both indicated to me previously that solar panels in and of themselves are pretty resistant. So if you're in doubt, just have spare panels. I have spare panels. I have spare charge controllers. I have spare inverters. In the event that they fail, that's about all I can give you on the solar panels. But I think they're going to be a lot more reliable than, say, a generator over
Or
the.
the charge controller? I guess. Yeah, the really intricate stuff. That lines up with actually I think I saw a study that was like up to 100 kilovolts a meter.
Yeah.
Solar panels are pretty resistant.
Now,
But again,
now,
it
now
goes
you got to remember when they say 100,000 volts per square
goes
meter, that's per square meter. So if
true.
you have a 12 or 10 gauge wire running through that meter, you're not getting the 100,000 volts. You're getting a very tiny sliver of that 100,000 volts. So I did the math on that some years ago and calculated that with a 10 gauge wire, you're actually getting about 50 volts per running foot of wire. So if you got 100 feet of wire out there, that's 5,000 volts.
Yep.
So MC cable stands for metal clad. You can buy it at any hardware store like Lowe's or Home Depot. Um, you can buy rolls of MC cable anywhere, and it already comes with the wire in it. You don't have to, feed it through there, and you just use that instead of what most solar installers use. And I think your equipment will probably work.
Fantastic. I guess in that vein, Dean is asking the product EMP shield is supposed to protect a house and vehicles from an EMP. Does it work?
I've had two electrical engineers review that product, and they have no confidence in it. And
Yeah.
one of them actually did work on EMP related equipment back in the 1980s. And I, that you got three or four 14 gauge wires sticking out of this little box. I I don't put much stock in it.
Yeah.
By the way,
So the,
while you're on the vehicles, Bronzicotis oversaw the testing of about 130 vehicles at the for the EMP Commission on simulators to up near or 50,000 volts per square meter. And after the conclusion from all their testing was they expect about 94% of the national light vehicle fleet to survive. That's based on testing vehicles that were made before 1995. Now, with the new cars, back then, a car had three or four electronic control units and a little metal box in the car that controlled your taillights and brakes and engine function and so forth. And now your average car has over 100 ECUs in it. And I don't have any current data on that because the EMP Commission's been suspended for a few years. Now, vehicles that are not running at the time of insult, they always started and ran. You can always go to a car lot. Vehicles that were running at the time of insult, some of them, I'm trying very hard to pry this information out of Bronsacotis. He's very afraid of telling me too much. He said some of the vehicles didn't even stop running; they just kept running. Some of the vehicles stopped, but could be restarted right away, and they would run. And some of the vehicles stopped, and you couldn't restart them until the battery cables had been removed and the vehicle left to sit for about 10 minutes. And sometimes the electronic control units would like reset and you could replace the battery cables and start the car. After 2 or 3 insults, that didn't work anymore. And as far as brands and model years, he said, the only thing I will tell you is Ford Motor Company has its own EMP simulator. And he said, of all the products they tested, Dodge Chrysler products were the worst. So hope that helps on the vehicles.
Absolutely. Thank you. Yeah, we're getting close to time here, and so I'm going to try to rattle through a few of these last questions here. You're staying in the EMP vein, and then there's a few others that are separate from EMP topic that I'll come back to. A bit unrelated, will an emergency radio survive an EMP with just the antenna shortened and kept away from anything conductive, or is a shield necessary?
Um, Solark does a very good video on YouTube. They put several handheld radios in a small galvanized steel trash can with a lid on it, and they zapped it at 50,000 volts. And they opened the cage and opened the container, and all the radios worked. And they said, so you can see how the Faraday cage worked. But then they took the trash can out and they put the radios in the simulator, closed the door, and zapped it again at 50,000 volts. And all the radios worked except one. And if they took the battery off and put it back on and started it, the radio worked. So, it's a small device. It doesn't have a lot of antenna hanging out there to suck up EMP energy. So I think most radios will still work if they're not tied to a bunch of coax and a big antenna. If they're disconnected, I think they'll work. Your
Exactly.
mileage may vary.
What is a good solar panel and a solar generator if everything gets fried? If everything gets fried?
Well, Solark manufactures hardened panels and hardened inverters and charge controllers. And you can go to their website, SOLARK, and they'll be happy to talk with you on the phone. But that's the first place I'd look. I did buy 8 of their panels, and they're stored. And I did buy one of their inverters. So that's where I'm at on that.
Awesome. Let's see here. I think we've got 3 more kind of brief ones. The final one for EMP. Let's see. The EMP doctor on YouTube recommends some products like Simon's, etc. Would those be worth it?
I haven't looked into that, so I don't know.
Totally understandable. That's there. And ah, suggestions for how to boil water without power safely and indoors without giving yourself away, etc. And for heating in your area.
Well, that depends on what you're using for an energy source. Yeah, I mean, no, yeah, if you can boil water, with electricity, which is what I do with the solar equipment, nobody's going to know. But the boiling will not get rid of chemicals in the water. So if you've taken water out of a stream that's got, arsenic and lead in it from a mining operation, that's not going to be good. Um, if you have a metal processing plant nearby, there you might run the risk of dissolved cyanide salts in the water. Boiling will not take care of that. Distilling may reduce that risk, and we have a chemical engineer on board here who might be able to illuminate on that. Do you have an opinion, Jay, on distilling for getting rid of things like heavy metals and dissolved cyanide? No, he's not on the mic.
Oh,
Yeah,
sorry, I
he's
had to unmute myself. Um, yes, well, if it's something that's non-volatile, like heavy metals and things like that, it does a very good job. Heavy metals and salts that don't have much of a vapor pressure, you can distill the water and leave most of that stuff behind.
Thank you,
Um,
Jay.
a carbon filter will also take it all out.
I don't know about the metals though.
It does a pretty good job on metals as well.
Really?
Yep.
That's good.
Yeah.
Thank you, Jay.
No problem.
You can buy a small distiller that'll fit on a cook plate. We just bought one a couple years ago, which is important to me because I have to use distilled water to fill my forklift battery. But
final
Hey,
question, actually.
Paul, sorry,
Oh,
Paul, I have a question. So let's say that you can't afford a $6,000 lake water system. Do you have any suggestions on a affordable water filter device, maybe a portable one? Maybe it's not perfect,
yeah,
but
well, if you
what's a good one that people can rely on that'll get them good water?
um the key thing here is to pre-filter out the coarse particulates before it goes into whatever filter you're using. For example, if you buy a Live Straw community filter, which is like a ceramic based um, zero point zero 0.01 micron filter, if you pre-filter all the coarse sediment out before it goes into that filter, then that will vastly extend the service life of those filter candles. So, um, I'm absolutely open to sharing source material with anybody that wants it, and we can mix and match something that'll fit your budget. Um,
Okay. So you're thinking live straw is
yeah,
good enough?
you can call Water Pure Technologies in Sandy, Utah. Craig Fairclough is probably going to be the one that picks up, and he has a number of options that you can use for like you can build a good water filter out of two 5-gallon plastic buckets and using their filter cartridges. You can get down to the virus level for under $200,
Okay.
but you're not going to be showering and washing dishes, with that.
Mhm. Yeah, I was just thinking most people don't have access, to a bug out
Location.
shelter, something like
But
that. So I'm
you
just
know, but
thinking,
but I
the
think in
average
those
person.
in those cases, they if they have that option on the top of their mind, and they make a friend with somebody who lives in the country, then maybe they can work out an arrangement that they can pre-position food and clothing and stuff at that location. Just
Good idea.
sometimes things come our way and we can take advantage of that.
Hmm. Yeah, great idea.
Final question here is what is the power consumption on that system that you were showing for kilowatts per hour per gallon on average?
Okay. Um, the water pump uses 15 amps, and the UV reactor uses 65 watts. But, like I say, if you run it for an hour, that's like 200 gallons. So that's like a week.
A lot of water.
A lot of water.
Yeah, it looks like I believe, I apologize if I missed anybody, but I think that's all of them. Thank you so much, Paul. I know we're a smidge over time. But unless anyone else has some additional comments or questions, I believe that'll conclude this meeting for today. So yeah, thank you so much, Paul, on just elaborating the essentially the copious amounts of issues that you're going to have to deal with both when the power fails and and ultimately the causes for it, of how it be it an EMP, cyber attack, what have you, it's going to have cascading effects that we're all going to have to think about. And it's something that you essentially you can't run from it. We all need water. So we really do appreciate you for taking the time to explain the best ways that we can ultimately keep ourselves and our loved ones safe.
Thank you, Parker.
Thank
Yeah, of
you.
course.
Thank you, Paul.
And I want to thank
Yeah.
Roseanne and Sharon and Jay for all the hard work that they do, keeping the wheels on this thing.
My pleasure.
Okay,
Bye, everyone.
Good night.
Bye, everyone. Have a good night.